Today we're going to learn lesson 6.2, Estimating Solutions of Linear Systems of Equations by Inspection. Okay, and you want to think to yourself, well, what does the word inspection mean? Okay, we'll think of an inspector. They look for things. So the word inspection means to look. All right, so let's write that down. All right, we're estimating the number of solutions of linear systems of equations, right? When we have two equations together that have two variables. All right, so our objective is going to be, I will determine the number of solutions a system of linear equations has by inspection. I will determine the number of solutions a system of linear equations has by inspection. We're just going to be able to look at the systems of equations and know how many solutions it has. Okay, as you can see from our little tables, or our little chart here, the graphical organizer, that a system of equations can either have one solution, no solution at all, that's interesting, or infinitely many solutions. I wonder what that means. Okay, so there's three types of numbers of solutions that a system of equations can have. So the key concept is, well, you're probably thinking, what is a solution? Remember we learned that it's any ordered pair that works in both equations, okay? And if you were to look at a graph, okay, on a graph, the solution, this is extremely important, is the point of intersection of the lines. Okay, so as always, when you have equations, you can graph them. And when you look at the graph, the solution to the system of equations, the ordered pair, is the point of intersection of the two lines. Okay, so let's look at what a graph would look like and what we need to know about the actual system of equations when we have one solution. Okay, here are our two equations in our system, y equals x minus 1 and y equals 2x minus 3. Okay, as you can see in our graph, notice here's our y-axis, here's our x-axis, and these two lines are graphed. Okay, I'm going to highlight the equations and then the lines. So y equals x minus 1, when you graph that, here's our two lines, that is going to be this line right here. Okay. So this equation, when you graph it, it looks like this on the graph, this line. Okay, the other equation, y equals 2x minus 3, I'm going to highlight that in a different color. And that's this line right here on the graph. Okay. Notice it has one point of intersection. Okay, the point of intersection, let's put a point there. One solution means there's one point of intersection. Because remember the key concept on a graph, the solution is the point of intersection. And see how there's one point of intersection. The two lines cross at one point. Therefore, there's one solution. Okay, let's say we didn't have the graph though and we just had the system of equations, y equals x minus 1 and y equals 2x minus 3. The way that you would know, this is very important, that there's only one solution is you want to check the slopes and the y-intercepts. Okay, for there to be one solution, they have to have, this is really important, because we might not always be given the graph, we might just be given the system of equations. To be able to tell that it has one solution is you want to look at the two equations, make sure they're in slope-intercept form, which these both are, y equals mx plus b. They have the x term first and then the y-intercept. The slopes are different. Okay, the slopes are different because obviously, right, if the slopes of the lines are different, then they're going to cross at some point. So you know that a system of equations has one solution if the slopes are different. Okay, well, the slope in the first equation, y equals x minus 1, is the number with the x. Well, wait, there is no number. So remember, if there is no number, that just means that it's 1. So the slope for the first equation is 1.